Welcome to Connect Online. This session will be focused on improvements in the eventing service. In particular, I'll be covering scalability, usability, and new features. My name is John Strabla. I'm a principal product manager of the server. In particular, I'm razor focused on the eventing surface. The agenda we'll be covering today will be a brief introduction on just what eventing is. Then we'll move on to improved scalability and improved functionality. Then I'll spend some time talking about pending enhancements. I'll be doing an eventing demo, and we'll cover an appendix, which is an invitation to go to the document set and try out some examples or scriptlets. So eventing, just what is it? Why Couchbase eventing? What's it going to do for you? Eventing enables centralized user-defined business logic to be co-located with a customer's core data service, thus allowing actions to be taken in real time in response to any mutation or change in their data. Eventing is a highly available, performant, and scalable service. It scales both vertically and horizontally. It can handle high volumes of mutations or data change events in real time. Eventing makes it easy to develop, deploy, debug, and maintain data-driven business logic via one centralized platform without any concern for infrastructure. Couchbase takes care of it all. Native to the Couchbase data platform, eventing requires no additional third-party solutions to license or no new data ops skills to manage this additional core real-time cluster feature. To recap, eventing allows you to develop, deploy, and manage dynamic data-driven business logic with no focus on infrastructure. So, let's take a look at what the eventing service does. It allows you to do more with change. Think of database triggers. You're responding to every mutation or change in your data. So here I have a picture on the right of several applications on the top and several potential integrations on the bottom. And over in the middle right, I show an eventing function. So if we watch a data mutation come from, say, the shipping app, we'll see that we'll end up doing real-time server-side event processing. It's easy to develop, deploy, and maintain. It's highly available, performant, and scalable. We bring data-driven business logic closer to the data. It's triggered on data changes or mutations when the data changes or mutates. And the native integrations that we have are the data service. We have KV integration via direct JavaScript maps that are transparently bound to buckets so that you can work with your data in JavaScript just like it's an object or a map. We have embedded N1QL integration. That's SQL for JSON. Anybody can pick up nickel in a day if they know SQL. This is like a defining feature on why our customers love Couchbase. It has curl integration. It allows you to talk to external REST endpoints via curl. And finally, every eventing function has application logging. Although this is merely a log file that you can put logging statements in, some customers use systems like Splunk, for instance, to tap into the log files and send them to like a global processing. This isn't commonly used, but it is available, and it is a way that the eventing service interacts with the external world. With that said, what do you use eventing for? Well, we can enrich or alter content in real time. We can trigger routines at specified intervals via timers. And we can propagate changes to other systems, whether it's a Couchbase system or an external system via the native integrations. So as I was saying, we have a shipping app. If we look to the upper right, we get a data mutation that comes in to the Couchbase server. It responds to a mutation, and through DCP, Eventing gets that mutation, and it can do things with it. It can change something in the database after calculating with JavaScript, or it could set a timer that will respond sometime in the future. And when that timer fires, could it be weeks later, it can do something with the data and the context information stored with that timer. Now, we can't just limit ourselves to one function. That wouldn't be incredibly useful. The Couchbase eventing service allows you to have multiple functions. Typically, customers have between 1 to 15 functions. We recommend that no more than 30 functions be used with the current release of Couchbase. So, the eventing service gives you application agility and flexibility. Real-time actions, centralized business logic, data validation, document enrichment, document transformation, data service integration. If we look on the picture on the right, Eventing is a DCP client. That's database change protocol. The database change protocol is a fire hose. Although there are some integrations, such as Couchbase's Kafka connector, DCP has so much ability to stream data that it's very rare that anybody can code something that can keep up with it, let alone do things properly. Eventing abstracts away the difficult to use API to talk to DCP and makes it simple to use through small JavaScript functions. And we respond to any create or update via a handler that's called onUpdate. We respond to any delete via a handler that's called onDelete. And we can have multiple eventing functions, and eventing functions are attached to buckets. Buckets can be considered either a database or a table. They're a logical pool of your documents. So we also have nickel integration, timers for deferred and recurring actions, and we have external integration via curl, and as I said, we have application logging. So what is an eventing function? Here I show a function that there is an entry handler. It's called onUpdate at the top. So we have this onUpdate handler, and it doesn't do too much, but it can be very powerful. The first thing that I'm doing is just logging. Hey, I got a document of document. There was some change to the data. If the data was deleted, we would have an onDelete handler without the document. It's already gone. But we'd have information like the meta, which is metadata, like the document key in the KV store. So back to what this function is doing. We log some information. We take two integers, okay? And we want to show the range of IP addresses. So we're essentially taking an IP address and converting it to an actual number so that we can calculate ranges. So we're enriching our data, and then we're writing back to the source document. And essentially what this does is I have a document that has some string-based IP addresses, and I'm basically going through looking at this document, and I'm writing IP ranges that could be used for some indexing or higher speed searches from the Couchbase database. And the second function is not an entry point, it's just something that calculates the number. Here's another small function. The onUpdate handler gets a change. Any change that happens, it takes a large master profile, whittles it down, and makes a smaller one, and writes it to a bucket, a different bucket, that's shared from an on-prem database to an off-prem database in AWS. So the business partner can can get information from a master profile, but not see some of the confidential or highly secretive information like credit card data or social security numbers. And yet another one would be cascading deletes. So as I said, the other entry point into eventing is the onDelete handler. We don't know what was deleted, but we do have the key. We can use the key to look up and create other keys for other related documents, and we can do deletions of related documents. And as you can see, I took a numeric ID where I parsed it out of the ID, which was the input key, and then I passed that to nickel. And this is just nickel written right into the JavaScript code. And it looks like SQL, and it runs not quite as fast as KV, maybe 10 times slower. However, it's very handy. So I'm just going, hey, if that user ID equals what I extracted out, let's get rid of all the transactions associated with that user that was deleted. So in real time, the system can automatically clean itself up. Now, eventing has improved scalability that occurred in 6.5.1 and also in 6.6. Each function now deploys in near constant time, approximately 18 seconds per function. We support 30 functions and 30 buckets. In the past, this was much, much lower. So in release 6.5, the total time to deploy 5 eventing functions was exponentially increasing based upon how many buckets you had. So we only supported 10 buckets in 6.5. People could squeeze a little bit more, size out. But as you can see, we had almost an hour at 20 buckets, 2,848 seconds. And when we had 30 buckets, when we tried to deploy 5 functions, we typically failed. Now, this all changed in 6.5.1 and 6.6. The time to deploy 5 functions now is 89 seconds if you have 30 buckets and 80 seconds if you have 2 buckets. This is a massive improvement. Now, the reasons that you'll want to upgrade to 6.5.1 and 6.6, specifically 6.6, scaling. Eventing handlers deploy much faster, as you saw in the prior slide. 6.5.1 eliminated exponential time to deploy n functions, which was related also to the number of buckets. Eventing processing is faster, 50% faster with simple handlers. The eventing UI is more responsive. It's optimized the HTTP communications. There's no more need to refresh. Under the hood, when you were bouncing around the Couchbase UI, there were some zombie threads that kept requesting the same data. And as you went back and forth, the UI appeared to slow down. This was an eventing specific problem that was solved. Eventing officially supports up to 30 buckets now. It used to be 10. Eventing officially supports up to 30 functions. It used to be 10. This allows you to do more with less hardware. Now, improved functionality. Come the 6.5.1 and 6.6 releases, eventing has improved functionality. The ability to modify documents in the function source bucket simplifies code and architecture. The recursive mutations, when you do this, are automatically suppressed. Think about it. I get a mutation from the source bucket, and then I change that document in the source bucket. Eventing will automatically suppress the recursive mutation, which would be an infinite cycle or infinite loop that could crash the data service. And I don't need an additional bucket. I can just fix things, enrich things, clean things up, change things in the source bucket based upon any mutation, or if I deployed with a feed boundary from everything, I can completely transform every document in my source bucket. It's supports in-place document enrichment. It's a great to write one-off tools. So what's happening in the below eventing function? Let's take a look at it. It says if the document type is not equal to customer, return. So we're only going to operate on documents that have a type of customer. Then we're going to say, let's set our customer ID to the field customer ID. And then we're going to set up an iterator. And we're going to set the iterator up via nickel. And we're going to do some information with it. And we're going to run through this iterator in a for loop. And we're going to make a particular scoring algorithm. We're going to say, gee, if we have more than n items in a given year, then we're going to enhance our score. So we walk through this, and at the end of this cycle, we set a loyalty. It's a new field applied to every single document in the database. We set a loyalty, and we score it. So we enrich the original document to have a loyalty score. We write it back to the source bucket. That's it. So we entered with a customer record that had certain fields. And we exited after we deploy from everything, or we leave this running in real time forever, and we always get a loyalty score on every mutation. The ability to modify the documents in the function source bucket has much higher performance than using, let's say, nickel. So here we have a couple items, okay? So I'm running different things on the entry point. And the comments above show you when we use KV or the data service, it takes 1 millisecond. When we use the nickel service via the direct key, it takes 420 milliseconds. When we use the nickel service with a where clause, we take over 900 milliseconds. That's a 900x increase in performance. Now, more reasons to upgrade. We now have production support for curl inside of Eventing. In 6.5.1, this was released, and there are some quick scriptlets that allow you to see exactly how and get up and running with Eventing via a get or a post. The Eventing curl implementation supports multiple authentication methods, no auth, basic, bearer, and digest, with more to come. Now, some more reasons to upgrade. 6.5.1 introduced pause and resume for your eventing handlers. Essentially what this means is that when you pause a function, there is a checkpoint made via the database change protocol feed for every vBucket. There's 1,024 of them. So Eventing has a placeholder on exactly where to pick up. This allows you to edit your JavaScript logic while paused, or even allows you to change your settings and adjust things while paused. Let's say you deployed your function, you don't think it was running fast enough, you could pause it, go into settings, change the workers from the default of 3 to 8, and then resume your function without missing a single mutation, picking up exactly where you paused. That's done, of course, via the resume. So the handler starts on the very next mutation. Nothing is missed. This is huge. Further reasons to upgrade to 6.6.0. This is new functionality. So we have a per function key statistics are now co-located with each deployed function's handler's control. So when I deploy a function, you get these statistics that'll just show up, that'll show your progress. I think they'll shift over to showing millions when you get over 10 million, else they'll show individual integer counts. So this really helps you accelerate development and highlights issues via immediate feedback. Take this particular function on the lower left. I forgot to put var or let in the function. It's a JavaScript error. When I deploy the function, which I happen to deploy from everything, I immediately see, oh my gosh, I had 6 million plus errors. Actually 600,000. So what I do is I go into the function and I can see exactly where the error is happening. Okay, if I moused over the red X, it would tell me a little bit more information. So there's no more switching between screens in the UI to go to like server, statistics, scroll down, open up the deployed eventing function to see this particular stat. And you would have graphs and numbers there, but this gives you immediate feedback as a developer. Hey, something's wrong. Let's stop it. Let's fix it. More reasons to upgrade to 660. The ability to differentiate between expiry and delete in the onDelete handler. Okay, there's an example that you can run through and test this out yourself. The onDelete handler now has an optional parameter called options. Okay, the optional parameter options indicates if the document was deleted or expired via the Boolean options expired. This allows more use cases to be supported in eventing. So let's look at the function. If options expired, if that Boolean evaluates to true, we know it's expired. Else, we know the user deleted. Consider that we might have had a bucket with a TTL set. Well, when that TTL hits, it might have been 90 days. That's the normal course of things. The document was expired. Now, if there was a real deletion, well, maybe we want to take a different action on that because something else happened that wasn't in the normal planned course of things. The new capability allows this different sort of logic to be executed depending upon the type of removal. Okay. Note, you can always use onDelete meta. It's backwards compatible, so you don't have to change your eventing function. Easy recurring timers. In 660, this is now trivial to do. Recurring timers are fully supported, i.e., a function that is invoked by a timer callback can reliably create fresh timers. This update, come 660, allows a single function to reliably implement a complex recurring events using callback functions via creating a new timer within that callback function, okay? So, or even other timers within the callback, all right? There's an example that you can follow in the main doc set. Previously, we needed an additional helper function and an additional bucket to do this. And we had to turn off inner bucket recursion safety checks. So in 651 and 6.0 right here, we would have to have an additional onUpdate, and it had to work with a helper function to do the same thing that a single function with one bucket can do. It greatly simplifies creating repetitive logic. Timers can now be canceled or overwritten. So prior to 660, if you had a timer and didn't want to use it, you had to put a flag in the timer, and then when that timer fired, you had to check another document, then look at the context, then look at a flag in the other document and say, oh, I really don't want to run this anymore. Well, no more. Come 660, eventing timers can be canceled. So you can actually use a timer reference as opposed to having a unique reference for every timer in 651. So a timer reference can be fixed, and you can just simply cancel the timer, or you can overwrite the timer with a new context and also a new time to fire. This simplifies the logic greatly and allows easier business logic that makes use of timers. Timers can now be created days, weeks, and years in the future with no adverse performance impacts on an otherwise idle eventing system. This ability opens up use cases for long-term notifications and customer engagement and re-engagement. I list the MB, public MB, where you can look a little bit more on what was happening in 6.5 and 6.5.1. Due to a regression, depending upon how your system was running, if it wasn't firing timers all the times and you had lots of them and then your system went idle, e.g. no timers were firing and all the timers were set well into the future, without extensive workarounds, and there were workarounds, your timers could, if they were more than an hour or 2 or 3 in the future, have increased number of bucket ops. This could result in eventual starvation in several hours or days by increasing the number of bucket ops. It was a bad bug, but there was a way to work around it. Well, this is solved, and timers in the future no longer are impacted by this problem. Okay, to conclude reasons to upgrade, I'll give you some customer viewpoints. Here's an unsolicited endorsement from one of the top 5 largest US companies. This is by market cap. 660 provides a basic diagnostic info, a set of statistics in the UI, like what's the backlog size, how many events are processed, how many are in the error, etc. This is really useful. Now, what I like the most, the eventing service should be used on CB 66X version. The new improvements make all earlier versions feel like they're in beta. The eventing service is now becoming so mature, and the improvements for usability, customers are raving about it. So upgrade. If you're going to use eventing, use the latest and greatest. You will not be sorry. Now, let's talk about some pending enhancements. I'm going to just say safe harbor. You can go look up a safe harbor statement. However, I'm going to let you know these things are slated to come out in the next month. They're coming out in November. And so what are you going to see in November? Rebalance will be automatic. No longer after you do a manual failover for eventing do you have to hit rebalance. It will happen automatically. This will simplify. It'll make things seem better as far as fault tolerance is concerned and more uniform across the Couchbase data platform. You will also have advanced bucket ops. This is going to be a game changer. So like our SDKs now have CAS semantics, okay? This allows you to compare and set. You can manipulate things, you can tell if someone else changed things, and then you can do a retry so that, or you can reread the data and see what the change was and do a retry easily. This is a game changer. You will also be able to manipulate the TTL directly. This could give up to a 400% performance improvement for some eventing functions that were using nickel to manipulate the TTL. So what do we have? We have get, insert, where you can actually set and compare your CAS. We have upsert. You can't set and compare CAS. That's because we like to be lockstep with other SDKs. You'll have to use replace if you want to deal with CAS then. And we also have delete, where all of these you can specify CAS with the exception of upsert. And if CAS has changed on you, you'll get a notification that it didn't work. Then you can reread the data from KV and take appropriate action. You can also set the TTL if need be. So this is really exciting stuff. I'm looking forward to it. There'll be some great examples on the new website documents when we have 661. You should look forward to it too. We also have distributed atomic counters. Note that JavaScript has 53-bit precision. I mean, you might want 64 bits, but let's think about this a little bit. That is 9 quadrillion. Yes, 9 quadrillion. So if we look at this, millions, billions, trillions, quadrillions, you're really never going to hit 2 to the 53rd. And if you do, it would be incredibly surprising. So we have atomic counters that allow us to do Very interesting things. And as you can see, eventing's maturing, and these sort of upgrades and features are really exciting to see going into the product. So we did a big walkthrough. Now we're going to do some demos for eventing, and I think you're going to enjoy some of the things you're going to see. Our first demo will be data enrichment. Remember, several slides back, we started introducing eventing functions. This is the entry point, the handler on update. We can have all sorts of other functions that the entry point calls. There's another entry point called onDelete, but without further ado, we will take a look at what's going on. Data enrichment is indeed the very first example in our eventing document set. So let's make this all work. We have two required buckets, metadata, which is a scratch pad used by all eventing functions. You can share it among 30 functions. No need to have 30 separate buckets. In fact, that's a waste of buckets. And we are going to be using the source bucket, okay? And the source bucket will have documents that we change. We're just going to assume the only type of document that we're going to put in here is a document that has our IP addresses that we want to work with. Now, to create an eventing function, we need a source bucket. We need the common scratch bucket, best practices used across all eventing functions. We need a name. So we're going to go data enrichment of IPs. Binding type, I'm going to give it a bucket alias, and I'm going to call it either source or source bucket. Very important that this JavaScript map that we create via an alias is read-write, because we're going to actually update things in real time. Every mutation or change, we're going to double check something and we're going to do something. Okay, so we have to have read-write because we're going to write back to that same document that mutated. And so this alias becomes a JavaScript map in our function. Next, we're going to add some code. When it initially comes up, we get a template, and I'm going to paste in some code. The interesting thing here is the source bucket is an alias to source bucket, okay? And this just works like a standard JavaScript map or object, and it's really cool. We can actually change the document or add things to it and just write it back, and boom, we've enriched our data. So we'll save what we did, and we'll go back to eventing. Now, just so that you know, this particular example actually has a case 1 and a case 2. Case 1 writes to a different bucket. Case 2 writes to the same bucket. So scrolling way down, I'm doing case 2. In this example, we're using an alias of source. I used an alias of source bucket. So the examples are almost identical, but I just wanted to let you know about that. So now that I have that function in, we're going to actually stick in a couple documents, okay? So let's go back. Here's our function. Let's deploy our function. Since there are no documents, it doesn't matter the feed boundary from now or everything. We just want to get this function active, okay? And it'll take 12 to 18 seconds to deploy. While it's deploying, let's go and add a new document. So we're going to add a document. I'm just going to call, the first one will be key 1, and then we're going to stick in the document, and we're going to do the first one. Everything looks legal, country AD, and it has an IP address, okay? A start and an end. Now, pay attention to the bottom of this. I hit save. Instantly, in real time, we've got something that happened. And you know what? I did something wrong here. And it was on the tail. Tail-F. There we go. So let's just change this to 2, okay? So I'm going to save this document. Oh, boy, it started, and even though it had a different range, if I look at it, because I changed it, There's the range. The range is 674. Okay, so we're printing the entire document when it enters the eventing function. And this is in real time. I could just say, gosh, let's delete. Okay. Automatically repaired. We take a look at our document again. Automatically repaired. So in real time, we're forcing these two new fields. Okay, we can do anything we want. We could change this to 6.1, get a greater range. Okay, now this works on one document. It also works on two documents. We'll make key 2. And remember, oops, sorry about that. I'm going to have to go back and pull this second one, this IP in Russia. And we'll paste it in, we'll save it. And it's working on this other IP, key 2. And that's been updated in real time. So one of the things that's cool is that we're enriching things on mutations. People can mess things up. We can get a new document. It always gets new fields added. So imagine that we had an application and version 1. We went to application version 2. We can use eventing and deploy an eventing function because version 2 might need this. Version 2 might require these fields. Version 1 didn't, but version 2 runs so much faster because it has to know the range and it has to quickly calculate it, okay? So we can have both sets and everything's working, and eventually we get all the web servers that have version 1 upgraded to version 2, and then we can run another eventing function to delete the old things that we don't want. Kind of cool. And so we can, our example, I'm only showing 2, but we could have easily had hundreds of thousands of these. So let's go back, and before we end this demo, let's just take a look at what our JavaScript looks like. The only thing we're printing is what the document was when the mutation happens. We're changing it and we're updating it. Pretty simple, easy peasy. And this just shows you the basic functionality of eventing. On to the demo. So here we have 1 million documents, and this is a master profile, and the function is going to whittle down the master profile, strip out sensitive data like Social Security and credit card information. So in order to show how all this works, we obviously have to load our eventing function. And in our eventing function, we have set the number of workers to 12 for performance reasons. We have a bucket alias of AWS bucket to a real bucket called destination, and it's in read or write mode. The code is fairly small, and it just picks out the stuff that we want to share with our business partner that has a Couchbase server in the cloud. We're going to deploy this, and I want you to pay attention to the performance. This will take about 12 seconds after the function is fully deployed. And remember, this is a very small server. It only has 12 cores, and it's one box, and it runs everything on the same box. So it's about ready to start up. We're already about 1/4 done, about 1/2 done, about 3/4 done. And we have 1 million shared profiles that are created in another bucket called destination. We take a look at our documents, and as you can see, it's a much whittled down profile. Master profile is now shared profile. Once everything is in place, what I'm going to do is I'm going to take a I'm going to create an index just so that I can do something. I'm going to mutate 10,000 documents. And when I mutate these documents, I also want to see how long it's going to take. Under 651 on, we can pause an eventing function and edit it. And it just puts a little placeholder right where you were. And I want to do some timing. I want to prove just how fast eventing is. Okay, I'm just going to simple, a log statement. I'm going to save that, and we will resume the function. And remember, I just made an index. The reason why I made an index was so that I could run a query function to mutate 10,000 documents. So when this gets deployed, we'll see that we picked up where we left off. There were no mutations. So we're going to take a look at our log file, completely empty, but we will log a message for new mutations. So I want to show you with two windows exactly what's going on. So we're going to go to the query editor here, and I have something in here that will actually take 10,000 keys, offset it, whatever I want to offset, doesn't really matter. I could offset, 500,000, 300. And that's the way we're going to mutate our documents. So I'm just going to execute this. This will take about 3 seconds. And this is what nickel takes. So 2.7 seconds. Nickel took that. You saw we're already done. And in our log file, we have 10,000 lines as expected. And how long did this really take? Let's see, it took 2.7 seconds. So eventing was keeping up with what nickel is. Eventing can run much faster. So what I really wanted to show you is that even though we took 12 seconds to load 1 million profiles, okay, when things change in real time, we're updating things in eventing in real time. On to the final demo of the day. A few slides back, you should remember we were talking about cascade delete, okay? Let's see how this actually works. So you can do this on our main doc site, so walk through at your own convenience. Cascade delete is a step-by-step example. It has a great deal of detail. I'm very interested in just copying the script. It's copied. We're going to create 3 buckets: metadata, transactions, and users. I've already created them all. So we're ready to add our function. I don't want to import, I want to add. So users will be the source bucket. Metadata. Function name will be cascade delete. I'm not going to add any bindings because I'm really not going to do anything else but clean up orphan transactions. Let's look at our template of code there. We get rid of it and we paste in what we copied from the step-by-step example. So there's 2 entry points. On update, we'll really do nothing. It'll just print some information. It's a no-op, okay? I could comment out that log file if I didn't want to be bothered, log message. And on delete now, in this example, the prior 2 were using the on update entry point. We don't get the document, we only get metadata, which is typically the key and some other information. And that will allow us to do something and delete related items in a different bucket from what the mutation occurred on. So let's see how all this works. So we've saved our thing. We're going to deploy. Doesn't matter if the feed boundary was everything or now because we have no data. But in order to get our data, this particular example has some data sets. Just copy. We go into the query monitor and put in some data. Success, it's happy. Let's go into our query monitor again. So those were users. Let's do our transactions. Delete what we got in here. Paste. Run it again. And the last thing, since we will probably do some nickel queries just to see what the heck's happening, let's do some, put in a couple indexes. And so now that our function is deployed, let's do a tail -f on the log file. Okay, so remember I said that there would be some no-ops. So we put in some users and the no-ops were on the onUpdate function. It just says what the users were that we put in, okay? So what we've got going here is, and something's wrong with my screen. There we go. Now I can see things again. All right. We're going to go look at our buckets. As you see, I have 5 users. I look in documents. And I have 9 transactions. These transactions might be related to specific users. Well, it looks like transaction user ID 100. Looks like there's 4 of them. Let's blow away user ID 100. Okay. Now we could do this, via the SDKs. We could do this via the query monitor or the query workbench, or we can just delete user 100 right here. Delete it. User 100 is gone. All right. So let's take a look. Oh, wait a second. OnDelete removed orphan transactions for user 100. Let's go look at our transactions. Yes, indeed, it removed them. Cascade delete. Kind of cool, keeps your database completely in line. It's a trigger. And this really shows you yet another use case and the power of eventing. Okay, that concludes the session. This presentation is now essentially over. I hope you enjoyed your time. Once again, I'm John Strable. I'm the Principal Product Manager of Eventing here at Couchbase. I look forward to meeting and answering any of the questions that you might have had during the session. So thank you. The appendix is merely a copy of our documentation website. We have 9 step-by-step examples. I implore you, if you're interested in eventing, do at least 2 or 3 of the step-by-step, if not all 9. Learn what eventing can do via these step-by-step examples, and then move on. Once you have a hang of eventing, scriptlets are a really easy way to learn what eventing can do, and the scriptlets will move on to some very advanced things. So enjoy, and happy eventing here at Couchbase.